Hi there, it's Mrs. Sullivan. We are going to cover section 3.2 today. Some materials you're going to need with you. You should have received notes for 3.2 in class today. You'll want your book open to page 106, a calculator if necessary, a pencil, and maybe some sticky notes again in case you have some questions to ask in class tomorrow. Yesterday, you talked about finding rates and ratios, and the last example you did with Mrs. Trombley dealt with a graph, and we're going to do a lot with graphing today. We're going to talk specifically about the concept of slope. Slope is a rate of change between any 2 points on a line, so it requires only 2 points. It is a measure of the steepness of a line, so literally how steep is the line. To find the slope of a line, you're going to find the ratio, which should sound familiar from yesterday, of the change in y, remember the y-axis is your vertical or up and down, to the change in x, which again is your horizontal or left to right. This is what we did when we calculated unit rates. So here's our first example. We're going to find the slope of this line that we're given right here. The formula to find the slope is the change in y divided by the change in x. Remember this symbol from yesterday, the little triangle? That's a shorter way of writing the change in y over the change in x. So the way we're going to calculate that, we're going to look at this graph. A couple ways you could look at this. We could say, okay, how far would I have to travel to get from this point to this point? You could count your vertical change, or your up and down, to get from here to here. I first would have to go up 1, 3. So my change in y is 3. Another way of looking at that is, if you look, the y coordinate at this point is 3, and the y coordinate of the second point is 6. How far is it from 3 to 6? Well, it's 3. Or change means difference, which means to subtract. How far is it from 6 to 3? 3. Now look at from one x coordinate to the other. We landed here. To get now over to there, we have to travel horizontally 2. So my slope is 3 halves, or 3 over 2. It is okay to leave a slope as a ratio that is an improper fraction, as long as the 3 and the 2 don't have any common factors. You can leave it just like that. Move on to our next example, and this one is also in your book. Our next graph shows us going from the point 0, 0 to the point 3, 4. Remember that formula. We're going to find the change in y over the change in x. Our change in y, again, we can count from here to here. We have to go up 1, 2, 3, 4. So that's our change in y. Our change in x, to get from here over to here horizontally, we have to go 1, 2, 3. Or again, how far is it from 0 to 4? That was 4. From 0 to 3 was 3. Again, 4/3 is an appropriate answer, even if it's improper. We do not want to change this to a mixed number. As long as 4 and 3 don't have any common factors, you are all set. Next example. We're in the negatives. There we are, way down there in the third quadrant. We're going from -2, 1 to a +4, 2. We're going to calculate our change in y over our change in x. We can count. Now if you notice, this line doesn't seem as steep as the other line, so we'll see if it has a smaller slope than the other two graphs did. To get from here to here, I have to go up 1, 2, 3. So my change in y is 3. My change in x is 1, 2, 3, 4, 5, 6. 3, 6. Bells should be going off in your head. Lights are flashing. 3, 6 is not an appropriate answer because you know that both of those can be divided by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. The slope of this line is 1/2. Next example. Change in y divided by our change in x. To get from 0, 0 to 5, 2, I have to go up 1, 2. And then I have to go horizontally to the right 1, 2, 3, 4, 5. Some of you may be able to really look at this and say, okay, I'm going from 0 to 12, or from 0 to 2, that's a change in 2 on the y-axis. I'm going from 0 to 5, that's a change in 5. You don't have to do a whole lot with that one.
Megan Sullivan, please call the office.
I have to call the office now. We're going to pause our video.